Hi, this is Koiro again with a new video, and this time it's an update on the 1581 board, sort of. Because I started to get sidetracked when I should start testing this, and my main goal was to test this with a floppy station to see if it started up and to see if the drive spun up, and yeah, seemed to be working okay. And my first goal to reach to be able to do that was to make a power LED assembly, and the power LED on this drive is two LEDs, and they are connected with a common anode in the middle of this plug, and then the cathode for each diode is connected to the pins on the side. The original 1581 board contains a breakout part for the LED assembly for the 1581 drive, but I'm just going to bend some normal 5mm LEDs and do a mock-up of the assembly, so I just have something to test the drive on. Then we have to see if this is a permanent solution when we go on to making the drive enclosure afterwards. So with that on, we're going to connect the power through the power regulator. I apply this with about 7 volts as normal. So I made this 3-pin assembly and connect everything together, and I power up the board. When I power up, the board appeared to be completely dead, and the LEDs just light constantly. And the first thing I do then is to check for a clock on the circuit. And the clock circuits for the 1581 is up in this corner here. You have the CAN oscillator here that delivers out 16 MHz, and you have the counter here. That's a binary counter that counts and divides the frequency. And you can see this here in the schematic. This is the clock circuit for the 1581, and you have the CAN oscillator here. And you have the counter chip here, and this counter chip, the 74LS93, is a quite simple circuit. You have the 16 MHz down on pin 1, and you have a counter here that counts constantly up to 16 and start again on 0. And that means that you have a flick for each time on this one, and you have the every second pulse on this one, and so on. So that means that you have 2 MHz down here on QD, and you have 8 MHz on QB, where it's just half the frequency. And when we measure this, we measure quite a good signal on pin 1 out from the CAN oscillator. Looks perfectly good, this signal. But on the output, both the outputs on QD and QB is just a low, about a half volt or something on this output. So there is no frequency whatsoever on this, and that means that this chip is bad, or there is something other wrong with this circuit. And the chip I have in this is a 74L93, not LS. That should not matter much. So I don't know what's wrong. And if the CAN oscillator have been, that you try to draw too much power from it, this will lower the amplitude on this towards 0. So I know that there is a signal and that it's coming in here, and that this chip is not doing anything with it. And that is where we stand. So I took out this chip and I tested it in the retro chip programmer, and it failed. Yes, as I was testing the 1581, I met another snag, and that is my 74LS93 chip was bad. And I did test it in the Retro Chip Tester Pro, and it came out as bad. The strange thing is that every 7493 chip I had, and I had the 3 different makes, and every one of them tested bad in the Chip Tester Pro. So I don't know what's going on there, but I do know that when I measured on this, I got the clock signal in on pin 1 from the oscillator, as you can see here down in the schematics. The 16 MHz oscillator goes into pin 1, that is the counter B on the 7493. But what I'm going to do, and you might say that the crazy Norwegian is at it again, I'm going to convert so I can use a 74 293 counter. And the 293 counter and the 93 counter is basically the same. This has the old scheme, the military scheme from the 554 ships from back in the 60s, where they had the VCC not connected diagonally as there normally is. So this basically is the same circuit as this, but with a totally different pin out. And we are going to go at it as the most economical way. So we have here the 93 chip that is from the 1581 board. And we are just going to connect up the wires that we really need. And say that this is the counter B that I'm going to need. And you have the R0 and R1 signal, they are just connected to ground. So I don't need them. And then I have pin 4, and pin 4 is not connected, so I won't need that one. Pin 5 is VCC, so that I'm going to need. And 6 and 7 is not connected. So on this side I only need the clock B and the VCC. And on the other side you can see here I have the clock C, and clock C is not connected. So that one I don't need. Clock B is connected, and that is connected to the clock on the VD7070. So that one I need. QB. And then I have G and D, and that's of course needed. And then I have clock D, and clock D is, as you see here, the one that goes to the 6502, so that is QD. And then I have QA, and that's not needed, and this is not connected, and clock A is not needed. So I only need 2 pins here, and I need these 3. So it's 5 connections from the 1581 motherboard that I need. And on the 293 chip, try to make these more evenly spaced. On this I have not connected on the first 3 pins. I have clock C, and that is not needed. I have clock B, that I need. I have a not connected, and I have G and D. And here I have, of course, VCC. On this I have clock D, so that is needed. And here I have clock A, that is not needed. And I have clock input A, that is not needed. I do think it's better to ground this than to have it floating. I'm not sure, but I will try that first. And I have clock B, and that is needed. This is the input from the crystal oscillator. And then I have the R0 signals, and those should be grounded. As we see here in the truth table, to make this count, one or both of these has to be grounded. So what I will be doing, I will be connecting these 3 together and have them down here to the ground, like so. And what we need to take care of then is that I need to transfer this, 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 this and this to the main board. And I'm going just to use the rest of the perf board that I used last time to do this, and I'm not going to bother much with schematics and stuff. This is maybe problematic to test if the Chip Tester Pro tests bad on this, but I will be able to test it in the 1581 to see if the clock signal is actually coming out on the QB and QD counter outputs. So that's what I will be doing in this video. So it is another TTL thematic video this time. I might use these kind of pin headers, and I might connect all the pins on the socket. This board is rather small, but I don't have much space up here. On the 1581 I'm going to fit this up here, so I don't have much space really. Yeah, I might going to just use this kind of pins. And if I see what I need to connect down on the board on this one, I have to be careful not to punch myself. These 3 pins I need, and these won't be needed. And I will need this one, and I will need that one. Okay, maybe that is a good start. Maybe we can just start and see that I need these pins. But how are we going to do this on the other end? On this I need to solder most of the pins on one side and just 2 pins on the other side. Yeah, maybe I just solder this up and solder wires to all these connectors and start with that. I think that will be a good start. I will just use wire wrap leads and connect those 5. Then I can afterwards place the socket and map the leads to the right pins on this one. This will be a bit more problematic as I need to short out some and connect more of the pins to ground. And by placing this in a socket, I do hope to retain the integrity of this. So, oh, I have already made a mistake. Like this it should be. Because then I have the 3 pins here, and I have this one, and I have 3 open, and this one, yes. Yes, like so. And then I'm just going to cut 5 pieces of wire wrap cable. And I remove some of the insulation from one end of the lead, so it's easier to solder. Yeah, then I just solder one end of each of the 5 wires to each of the 5 pins I have on this PCB. Then I got all the bits and pieces connected there, and then I need to connect the same on this one, and maybe here it will be the... Oh, I do have to check if this really will fit. This is my 1581 board. I do think this will be a tight fit because I managed to turn the board 180 degrees opposed to what I intended. I can just cut away some of these if it won't fit, but I do think that's not going to be a problem, so I can connect this like so. Probably would keep this a bit apart from this. I do have to check that I won't short out anything when I do this, and I think I am pretty safe if I do like that. Okay, so that it will be. And then I'm going to start with just soldering this socket in. Be careful not to heat anything that makes the pin headers warm up so that they will go crooked on me. I don't have the best of margins on this design, if you can call it a design and not madness. Yeah, like so, and this is of course that, so this is pin 1. And I can start with routing around this G and D that needs to be connected 4 places. Maybe I can just blob up the ground. I can try that. When I say blob up, it's normally that I connected a thin wire and just short out the pads here. Because if we see this from this side, I'm going to connect these two and that one with that one. And that is going to be connected with that pin header there. So here I just solder up the 4 connections that should be hooked to GND, and I also solder the GND wire to the pin header so that the GND connection is finished. When I made the 7407 replacement, I used a thicker wire for the GND and for the VCC, but that was for 2 circuits. This is only 1 circuit that stands on top of this, and it's an LS circuit that draws little power. And then it's just to hook up the 4 remaining thin wire wrap leads and solder them to the correct points. And for those of you that are screaming, are you really going to run 16 MHz to that bird's nest? I really won't do that. It's only 1 wire that will carry 16 MHz. The other is the divided frequency on 8 and 2 MHz. And I don't think that will be a problem. It's short leads and they're going straight into the socket. And I'm sorry, here I lost some footage, but now we are ready to test this circuit in the 1581 drive. Yeah, we are now ready to test this board, and I've hooked up power. I hooked up a 3.5-inch floppy drive through this adapter board, and I've connected my Special 7407. And I now connected my Special 7493 aka the 74 LS293 chip, like so here. And I connected the scope wire here to ground, and now I'm ready to measure the signals. But first I will try to turn this on. And last time I powered this on, there was light in both these LEDs. But the green light is lighting up and not the red ones. I don't know the orientation on this, so it might be the other way around. But anyway, it's a huge difference from last time, because last time there was only light, both lights. So now I will try to measure here on the clock signal. On the pins from the pin header, this should be the clock A, that's the input. And that's a nice steady 16 MHz, I think, on the scope. And that means on the output lines, that should be these ones up here, QB and QC, QB and QD, I mean. That should be, this is the QB. And here we have 8 MHz steady. And this should be, yeah, it's a nice steady 2 MHz, and they look nice. So I think I will call this a success so far. The clock circuit at least seems to be working, and we can also check the clocks on the 6502, of course. Yeah, and on the 6502, pin 37 should be the clock input, and this is 40, 39, 38, 37. And this has a nice 2 MHz, so the clock in is okay, and we should have the output clocks on pin 3 and 39, I think. 39 has a clock of 2 MHz. There are some rise and fall time, but it looks okay. And the next is on pin 3, and that should be this one. Also nice 2 MHz clock. So that means that we have clock in the circuits, and that is how far I get in this video. Next video will be to test the actual function of the 1581 with some floppy disk and a C64. Yes, and for those of you screaming at the screen and trying to pull out your hair just in frustration to what I'm doing, I have to make some explanation here, because after I shot this video I discovered this datasheet. And this is a datasheet from the National Semiconductor Manufacturer, and they have a datasheet that especially mentions the L versions of the chip, and that's also mentioned in the Texas Instruments guide, but it seems that some manufacturers have a different pinout on the 74L versions of the chip than the LS and the versions without any letter between the numbering. And as we can see, it starts out quite good. It says that the L93 can stand 15 MHz count frequency, and that's slightly above our 16 MHz frequency, but it probably would have worked. But when we see the pinout on this chip, we actually see that they have gone the 54 route completely, because GND and VCC is connected on the middle pins on this package. And that's not similar to even the 74LS93 or the 74LS293 that we ended up using in our design. And you can see the differences here, where I've taken a screenshot of both the datasheets. This is from the Texas Instruments guide, and here you can see that VCC is on pin 5 and 10, and here it is on 11 and 4. And also the other pins, clock A is on the same pin, but all the other pins have been shifted one pin over. And you can see the RO signals is 1 and 2 and 2 and 3. And you have the clock B input that was on pin 1 is on pin 8. And QB output and QC output, QA and QD inputs is grouped here on this chip, but over here they are grouped 1 over. So that means that I wouldn't have been able to make the L chip I have work in this circuit anyway. And that is of course a rather peculiar discovery for me, because I thought rather that I've seen everything in the 74 TTL line of chips, and I've experimented and used lots and lots of these chips over the years. But this completely, blew me away when I discovered this. So even though I made an adapter to fit a 74 LS293 chips, we now discover that there actually are 3 different pinouts for essentially the same chip. You have the 7493 and 74 LS93 that has this pinout, and you have the L that has this pinout, and you have the 293 that is essentially the same chip. It only has a different layout of the pins. It has a complete different layout. So there actually are 3 different layouts for the same functionality chip. And that completely slipped my mind to even check, because it's a rather absurd situation. But anyway, it seems that I have made this circuit work with the 293 adaptation, and I'm not going to bother to make a 74L93 adaptation. But I'm going to order some 74 LS93 chips to test them in the circuits afterwards. Yeah, and that's it. And this was a rather peculiar video. I often end up doing something completely different than what I originally intended, but this kind of got sidetracked really fast because of the misunderstanding about the layout of the 74L93 chip. But it ended out well. I did get an 74 LS293 to work in the circuit, so the adapter board works quite well. And I'm one step further to actually test the 1581 drive on actually floppy disks and a C64. And that will be my next part in this video, and I've named this video part 8.1 on this series, and I'm going to continue all the 1581 videos in this series with the 8-something numbering to keep them grouped together. So that's it for this video. It was rather longer than I originally intended. Please hit like and subscribe if you want to be notified when we post new videos. A subscription will really help out the channel. So, thanks for watching. Hope to see you in the next video.